Top floor, end of terraced and mid-terraced apartments are very difficult dwellings to make compliant with the Part L1A specification. We need to input the details of the project. We will use the full fill method of construction. It is an apartment, no flat roof. It is an apartment above the ground floor level. Usually apartments have intermediate concrete floor slabs. ACDs are no longer sufficient. If the new fee standard is to be achieved, we need to use the robust or enhanced details. This project is a top floor apartment with a pitched roof and with the insulation between and over the ceiling joist, so this option needs to be taken. It is end of terraced and the dwelling is a top floor apartment. As you can see, there are a lot of construction joints with this type of apartment. They have exposed wall and roof areas, and this makes design compliance difficult to achieve. We have more construction details. With this project, there are 2 exposed elevations and there is a small volume with these apartments. Compliance is also made difficult by contemporary apartment design, which has a lot of glass, and this can also cause overheating. We've collected the dimensions required by SAP on the thermal bridge calculator. Now let's design the Part L1 specification. Before we start into the design process, let us look at the thermal bridge. As you can see, it is over 0.08, even though we have used the enhanced details. This is because the length of the construction joints and the exposed areas with top floor apartments. The recommended Y factor is 0.05 when designing to the 2013 regulations. So let's go back to the first part of the specification to be designed, the wall. When designing a Part L1A specification using the Foresight system, the user chooses a performance level to design to, in this case the 2013 regulations. The designer chooses the structural materials and insulation materials to be used, and the software calculates the appropriate depths of the insulation material. The Foresight software knows that the recommended U values needed to achieve fee standard is not enough in this particular case, so they will present better U values to compensate for the bad Y factor calculation. Because this apartment is a top floor apartment, the software takes the designer to the flat ceiling design. The user chooses the performance level, the centers of the rafter, and the materials to use between and over the rafters, and the software will calculate the flat ceiling U value to BR433. This information is saved and used by SAP to calculate the performance of the dwelling. The sloping ceiling and flat roof section does not need to be designed. The areas not to be designed are locked, and the designer simply clicks on save and is automatically taken to the next section to be designed. The windows. The designer chooses the 2013 standard. 2 choices will be presented. If there is a lot of glass, the user should use a U value of 1.2 for the windows. If not, then the 1.4 value should be chosen. The doors and roof lights do not need to be designed on this particular project. Thermal bridge is very high, and we have already discussed this. Air permeability. The user chooses the 2013 standard, and the software will give 2 options. It is our advice that the designer chooses the 4 air exchanges with top floor apartments. Anything less, then a heat recovery system will be required. Heat recovery systems suitable for small dwellings are not common, and this is why apartments should not be designed to the extreme fabric standard. I believe this is something that the industry needs to look at. ventilation. With the air tightness chosen, we can use natural ventilation. Lighting should always be 100% energy efficient. Stoves as a secondary heating source are not suitable for apartment design, and a none option should be taken. Solar panels again are not suitable in apartment design, and a none option should be taken. Hot water storage. Combination boilers are most suited to apartment design and requires no storage tank. We are looking at the option of introducing community heating system, which we hope to have as an option fairly soon. Water usage. A none option should be taken with water usage for an apartment. Boilers. All our boilers have an efficiency of at least 90%. Heat control is now becoming a very important part of Part L1A design, and we are using a delayed start thermostat programmer. All the design decisions have been made, and let's see if we are compliant with the 2013 regulations. As you can see, there is non-compliance in the DER and good compliance with DFE. So let's go back to the design process. In an ideal situation, when the DFE is very compliant, as it is in this case, and the DER is non-compliant, we would increase the performance of the fixed building specifications or introduce low carbon technologies. We have used in this design process the most efficient boiler and heating control systems that are readily available. We cannot introduce solar panel stoves and heat recovery systems as they are not suitable for apartment design, so we'll have to look at the fabric for design compliance. Let's go to the windows. Because there is a lot of glass, we will increase the performance of the windows and choose a 0.08 U value or passive standard. We have an even better compliance with DFE, and we've just about achieved DER compliance. In some cases, even with the additional insulation and added cost of passive windows, DER compliance is not attainable. If this is the case, a decision needs to be made by the designer. Do they add the extra cost of insulation and windows to the build costs and still be non-compliant, or stick with the FE design? From our experience, the FE standard is as high a performance that can be achieved with apartments with the technology that is in common use at the moment. We do not offer extreme fabric design with apartments because low air exchanges cannot be achieved because heat recovery systems are not suitable in apartment design. As we have said before, top floor apartments along with ground floor apartments are the most challenging dwellings to make compliant with Part L1A.